Hello, guys. I noticed that would you want to indicate that you are connected or you are connected? That's the end sense of the subscription. I said subscribe so that once something is on, you have a notification. Are they connecting? Okay, I can see 2 persons connected. Okay. Now let's continue. Let's continue for this so that those of you that are coming late will join us later. Now, as usual, the man that is standing, the person standing before you is Dr. AMG. And we have planned to have an online class today by 4, though the network is epileptic, so we are still struggling with it, but I believe it will come to stabilization with time. In our previous classes, we have learned several topics. Now, the course that we are considering here is Mass 101. Now, and the topic that we intend to consider to cover is complex numbers. Complex numbers. Now, those of you that have been following, you are aware that we have considered the real number system. And we said the real number system consists of the set of natural numbers, whole numbers, integers, rational and irrational numbers. And their operations makes up the set of real number system. Now, you are aware that we have considered some quadratic polynomials or equations. And in it, you can observe that some solutions to the given equations are not really contained in the real number system. Solutions to some of the equations are not really contained in the real number system, such as x squared plus 1 is equal to 0. The solution to this quadratic equation is not contained in the real number system. Let's also consider another one, x squared plus 2x plus 5 is equal to 0. This one, the solution to this quadratic equation is not also contained in the real number system. If that is true, then we are saying that there is need for us to consider a larger system, an extended system that will also consider that of the entire real numbers and some of these that are not in the real numbers. That is why we said an extended system. Now, let's consider this to see it to illustrate what we're trying to say. Now, the first one we have, x squared plus 1 is equal to 0. That's a quadratic equation. Now, if you want to solve it, this you can solve as taking this to the other side of the borderline, and you have -1. Now, this you can also, making x the subject of the formula, you have x will be equal to the square root of 1. X is the square root of 1. Now, this that we have, you are aware that there is no number whose square is. There is no number in the real number system whose square will give you this, will give you -1. There is no number whose square will give you -1. Now, if that is true, then we are saying that there is need for us to use a symbol to denote this, so that whenever you see this, you use that symbol. Now, in mathematics, what we use is I, the symbol I, to denote square root of -1. So whenever you see I, we are referring to the square root of -1. Now, meaning that this solution here is this will be equal to I. That's what we have. It will be equal to I based on what we have said. Now, let's try to consider this quadratic equation. Now, you can see that in the real number system, there is no item like I. Okay, that's why we are saying that for us to be able to have for us to have these solutions, we have to consider an extended system. Now, let's also try to consider solutions of this problem. Now, with this, we have learned many methods of solving quadratic equations. One is the formula method, factorization method, and completing the square method. Now, for that of the formula method, we have minus b, x is equal to minus b, plus or minus the square root of b squared minus 4ac. Everything here over 2a. This is the formula that we use in solving quadratic equations. Now, the coefficient here is our a, the coefficient here 2 is our b, whereas this constant here is our c. Now, imputing all these into this formula, we are going to have minus b, which is 2, plus or minus the square root of 2 squared, which is b squared, minus 4. A here is 1, the coefficient there is 1, and c is 5. Everything over 2a, where the coefficient here is 1. Now, when you resolve this, you're going to have minus 2 plus or minus the square root of this will give you 4, minus this to this will give you 4, times this will give you 20. 20, everything over 2. Everything over 2. Now, this you can also summarize by minus 2 plus or minus, you have 4 minus 20. The answer here is minus 16, which is square root of minus 16, everything over 2. Now, when we're considering our sorts, you are aware that we said, given this we can also write as the square root of minus 1 times 16. This you can further simplify as square root of minus 1 times the square root of 16. Now, if this is true, given this one here only will give you 4, meaning that we have 4, the square root of -1. That is what we have here. Now, in place of this we can also write as minus 2 plus or minus 4, the square root of -1, everything all over 2. Everything all over 2. Now, from here, you can see that everything is off the job market. We have gotten the answer from here. 2 come here will give you 1, 2 come here will give you 2. So you have -1, x is equal to -1 from here, plus or minus 2 square root of -1. This 2 is gone. This is what we have. But remember when we started that there is no number whose square will give you -1. Therefore, we said whenever you see this, we use the symbol I to denote it, meaning that this we can also -1 plus or minus 2i. Where in place of I, in place of the square root of -1, we have I. Now, this that we have here is the solution of this quadratic equation. So we are saying that x is equal to -1 plus 2i, 2i, or -1 minus 2i. That's what we have. So solutions of this nature, we are saying that for us to have it, being that they are not in the real number system, we need an extended number system that will have all these variables. Now, there is also other equations that we may also consider. Let me give you one. This I will not solve for the sake of time. But then you can, I will give you the solution to that given problem. That is x squared minus 6x plus 34 is equal to 0. Now, this one, the solution to this one, this equation, is not also contained in the real number system. First, therefore, we must also consider the extended system. Whereas the solution, if you solve it, you're going to have x will be equal to 3 plus 5i, or we are saying 3 minus 5i. These are the solutions. If you solve it, this will be the solution of this given problem. Now, there is something I want us to note.
And it's disturbing me right now. The students are complaining.
So that is it. So you can see that these are the solutions of the given problem. Now, when you take a critical look at this, unlike the other ones that we're having, we used to have either x is equal to 2 or x is equal to another number, where their solutions is in the real number system. But for this one, for this very one, you can see that x is equal to 3 plus 5i. Like this other one that we considered first, we have -1 plus or minus 2i. Now you can see that the solution of this set of this quadratic equation is a combination of two parts. One is a part that can be found in the real number system, whereas the other one is not in the real number system. Now the term here is a real number. The coefficient here is also a real number. However, this part is purely real, but this other part is not purely real. Now, in this complex number, we call this part the imaginary part. This part is called the pure part. We have two parts, the pure part and the imaginary part. Now, for the sake of this solution, the pure part, the real part is 3. The real part is 3, which you can say the real part of x. The real part of x. The real part of x. Whereas this other part, which is 5, we say is the imaginary part. Imaginary part of x. So this first part, where there is no I, is called the real part, whereas this other part that has the I is called the imaginary part. So when we look at this and somebody says, what's the real part of this solution? The real part is this, whereas the imaginary part is this. Now, some persons may be tempted to say, if I say, what is the solution? What is the real part of if x is equal to maybe 2 plus 4, 2 plus say 3i? If I say, what is the real part? Somebody may say the real part is 2, yes, but the imaginary part is 3i. If you say 3i, then you are wrong. The imaginary part is just the coefficient, which is 3, Now, having said that, I will want us to quickly look at some operations or some powers of i's. Powers of i's. Remember, we have said that I is now square root of -1. I is the square root of -1. Now let's consider powers of I. Now, if I say I'm interested in I squared, if I'm interested in I squared, it means I am I'm squaring this side as well. Now, once I square this side, meaning what will be left here is just -1. Once I square this side, what will be left is just -1. Now, what if I'm interested in I raised to power 3? I raised to power 3. Meaning that, note that I squared was just 1 and I again. This one gives you this. The power here is 1, the power here is 2. So it gives you this. Remember that I squared is -1 already times another I again. So meaning that I raised to power 3 will give you minus I. Minus I. Now, if we're interested in I raised to power 4 times raised to power 2, which will give you this. But remember that I square is already -1. And if you square it, it's going to give you 1. It's going to give you 1. So look at how it goes. I gives you the square root of -1, whereas I square is equal to -1. I raised to power 3 gives you minus I, and I raised to power 4 gives you 1. Now, if that's true, then what of I raised to power 5? I raised to power 5. Now, I raised to power 4 is 1 already times 1 already, and times I already. So this one will give you I. I raised to power 5 is I. Now, if that's true, this I will give you as an assignment. I want you to go and consider, tell us when I is raised to power 6, I is raised to power 7, I is raised to power 39, I is raised to power 50, and I is raised to power 100. What are the answers? I want you to solve this out and tell me the answers. Is there any question? If there is any question, I will not want you to complain, but rather kindly drop them in the comment section so that we can respond to them quickly. Now, the next thing I would want to briefly tell you before I continue is, look at it. We have said that for it to be a complex number, it must have the real parts plus the imaginary part. The real part, a combination of the real part and the imaginary part makes up the complex numbers. They makes up the complex number. So for it to be a complex number, you have the real part and also the imaginary part. Now, a complex number where the real part here, the real part is 0, and you just have imaginary part, just say B, I. This kind of real part, this one is also possible for it to be called complex number. Yes, the real part, in this case here, the real part is 0, and the imaginary part is significant. That one is not 0. So this kind of complex number is called purely imaginary complex numbers. We call it purely imaginary complex numbers. Purely imaginary complex numbers. Now, a complex number where the imaginary part is 0, meaning you have maybe A plus 0. This one is called purely real complex numbers. Purely real complex numbers. Purely real complex numbers. Now, for it to be complex number, it must have real and imaginary part. Now, having said all this, I want us to quickly consider some algebra operations that are involved with complex numbers. Now, if we have, let's say we have xi, which is a complex number, we say 3 plus 2i, and we have another complex number, say x2 is equal to 5 minus 3i, 5 minus 3i, and you are asked to find x1 plus x2. You are asked to find x1 plus x2. This implies, having known that given that x1 is equal to this and x2 is equal to this, x1 plus x2 will therefore be 3 plus 2i plus 5 minus 3i. That's what we have. Now, how do you solve this kind of problem? You see that this side is real part, this side is imaginary part. You can't combine them together. Yes, the coefficient, what we have here is a real number. This one is also a real number, but together with the I is not. So you cannot combine them. Now, for the sake of this operation, you are going to collect like terms. There is a real part here, there is a real part here. There is an imaginary part, there is an imaginary part. So this you can also do by collecting this, and you're going to have 3 plus 5 plus then this and this again, where you have 2i minus, or say 2 minus 3 all into I. And if you solve this, you are going to have, if you solve this, you are going to have this plus this will give you 8, plus this and this will give you minus 1i, minus 1i. So this and this will just say is minus I. So this is the solution of x1 plus x2, x1 plus x2. So you can see that this is also a complex number. It has a real part and it's also having imaginary part. Now let's consider another one. Say if the operator is that of subtraction. Let's say we have x1 is equal to 4 plus 7i, and x2 is equal to 2 minus 5i. If we have that, how do we resolve it? Yes, this is also resolvable. This is also resolvable. If our interest is find x1 minus x2, this you can also do by just simply saying this one is equal to 4 plus 7i for the x1 minus into brackets 2 minus 5i. As I've earlier stated, this one is real number, this one is real number, so you concentrate on like terms. So 4 minus 2 will give you 2. Then 7 minus makes this one plus, so this becomes plus 12i is equal to x1 minus x2. So you can see that this one also resolves to a complex number where we have real part and imaginary part. In like manner, we can also carry out that of multiplication. For that of multiplication, if it's this we can also solve by, if our interest is to find x1 times x2, then this we can also write as 4 plus 7i all into 2 minus 5i. Now when you open the brackets, you are going to see that this will come here. If this comes here, you are going to have 8. If this comes here, you are going to have minus 20i. If this comes here, you are going to have plus 14i. And if this comes here, you are going to have minus 35. There is I here, dot I, which is I squared. Now, if you collect like terms together, here you have 8 minus, here is minus 20i, here is plus 14i. So if you resolve it, you're going to have minus 6i. Now here we have minus 35ii, but we know that I raised to power 2 is equal to minus 1, based on what we have said before. Therefore, here we have minus 1. Minus 1 coming here will make this one plus 35. So 35 to this will give us 43 minus 6i. So you can see that this one is also a complex number where we have minus 43 minus 6i. I want to stop here for the interest of time. Then we continue with conjugates of complex numbers in our next class. Thank you and God bless you.